All right, so we are going to still be finding volumes, but instead of those cross sections, you know, like a 3D printer kind of thing, it's going to be a solid that's formed by revolution, which means it doesn't mean revolution, you know. You're revolving a 2D shape around an axis, which you know how last time you had triangles and squares and rectangles and semicircles? All of these will be circles. They all go around in a circle. It's kind of cool this lesson landed on pi day because what did we just say our area of a circle is? They're all going to be pi r squared, all of them. So that kind of simplifies things. Also, it's going to, in a way, tell you if it's dx or dy. If you have a horizontal axis of revolution, which horizontal is this away, meaning the axis you're revolving around is horizontal, like the x-axis, then it's dx. And if you have a vertical axis of revolution, like the y-axis, then it's dy. So x-axis dx, y-axis dy. It makes sense, right? With me here? Horizontal is this way, okay? Vertical's that way. All right, let's go ahead and draw our first shape. Find the volume of the solid of revolution obtained by revolving the plane region bounded by. All right, what are some points I can put on y equals square root of x? 1, 1 is good. We kind of skipped one though. Where would we start? 0, 0, good. And then I'd like one more. 4, 2. Oh, if you're writing with pen, wait until I do the whole thing and then copy this because we're going to erase. Okay? But that's why I said it. Some people prefer to write with pen. You know, that's fine. Just don't draw that yet because we're going to erase part of it. All right, the x-axis, so that's this right here. And then the line x equals 4, so a vertical line at 4. So this is your shape that is going to be revolved. And what my suggestion is, erase all the tails that are outside of that shape so that you can concentrate on just that shape. You can take or leave my advice, but I'm not going to give you bad advice because I want all your answers to be correct. All right, so we're focusing just on this shape. So if you're writing with pen, that's what I want you to write down. So if you're writing with pen, just wait until we do the erasing and then go ahead and draw your picture. We are going to spin that or revolve it around the x-axis. So already this is going to be a dx problem, which is great. It's right side up. Everything is good. What I always have everybody do is draw what I call a ghost shape over the axis of revolution. So in this case, the x-axis. So it basically just a mirror image. Draw that down here. And what you have to have an imagination for is that you're taking this and spinning it around, and you have to imagine it as something three-dimensional. So it would be like a cereal bowl that you could not put any cereal in because it is solid the entire way through. Do you get what I'm saying? And all your cross sections, if you're thinking like the 3D printer, they're all circles. Do you get that? All right, I have a little video to show you. I just want to make sure I'm on the correct screen before I share here. So I'm going to share my screen. Can you all just watch this? And I'm going to make sure it shows up on the video. And that is this problem. It's your square roots of x graph. So this is what happens. You take it, you're seeing this? You spin it around. I think it's going to do it again. See, it spins like that, and you get this solid thing that we're going to find the volume of. Are you with me there? Okay, isn't that cool? It's cool, guys. This is neat. It's neat. Get on board. This is cool, guys. All right, so when you go to set it up, you're going to have an integral, and it is going to be, watch this, pi r squared, and then dx or dy. Pi r squared, pi r squared. They're all going to be pi r squared because they're all circles. That's why it's called the disk method. They're all disks. All right, so set it up blank, and then just go back and fill it in. You want x values for your boundaries because it's a dx problem. So look at your picture. That'd be where to where. You guys have been very good about that. On the AP exam, if they say set up but do not evaluate, the pi and the 0 to 4 is worth a point. So that's great. All right, now your radius, it's either upper minus lower or right minus left, like we've been doing all along. So look at this one. It's going to be the upper graph minus The lower graph is just what? Yeah, which is 0. Good. So you can kind of ignore that one. So your radius, upper minus lower, would be square root of x minus nothing. So just square root of x is what goes in there. Now, if these seem pretty simple, we'll do them by hand. If they seem really complicated, we'll put them in the calculator, okay? This one's pretty simple because what happens to your square root and your square to there? Yeah, it's like literally just x. So pi sits out front. What's your antiderivative of just x? Perfect. Such that 0 to 4. It is upper minus lower, but you can basically just plug in 4, because if you plug in 0, you're just going to get 0. And so what is that going to give you for your volume? 8 pi. Perfect. All right, let's try it again. Find the volume generated by revolving this region around the y-axis. Okay, so if it says we're going to go about the y-axis, already we know it's going to be what? dy. It would be a dy problem. It's going to be sideways. Now we're going to get our picture first, but that means some rearranging, and it means everything's backwards, okay? So what are some points I can put for x cubed? Yeah, 0, 0, perfect, and 1, 1, -1, -1, and then 2, 8 is going to go off the picture, but, you know, it's going to wiggle, something like that. If you're writing with pen, don't draw all of that. We're going to erase some of it. All right, the y-axis, that's just this. And then the line y equals 3. So that's a horizontal line at 3. So do you see in here, this is our shape that we're looking at? And so what you want to do is erase everything outside of that shape so that you can focus just on that part of it. I've worn out the eraser on my pencil. I'm going to have to use this one. So if you're writing with pen, this is the part that you want to draw. Like we're looking at this. So we want to spin that around the y-axis. Are you using your imagination? You're visualizing? It's going to be 3-dimensional, except it's solid the entire way through. So your ghost shape, that's what I call it, ends up over here. So you're drawing kind of like a mirror image. So it's going to be like a Hershey kiss, sort of, upside down. And now your discs are going this way. So when you go to set it up blank, it's going to be pi r squared dy. Just write pi blank squared. And then when you go back, you need y values because it's going to be dy. So that would be from where to where? Yep, 0 to 3. You guys are on top of that. And now your radius is right graph minus left graph. I don't really have space to put an r. I guess I can kind of. This is r and then this is L. But it's right minus left. This is your radius. So your right graph is this curve, but what do I need to do to that? Because I can't leave it like that. Set it equal to x. So you would do cube root of y. And again, I don't know why, but circling that helps people remember like what to put in there. So it would be that minus, what's your left graph? Just 0. Whenever it's the axis, it's easy because it's just 0. So right minus left, it'll just be cube root of y. We are going to be able to do that one by hand. It's just going to involve fractions, but you guys are pretty good at fractions, so I think we'll be all right. Pi integral 0 to 3. This will be y to the what? It's going to be a fraction. I know you're like, oh, is it 2/3 or 3/2? So it is one or the other. It is 2/3. Good. If that happens to you, let your like instinct kick in. You know what you're doing. Okay. The type of root it is the denominator. Because if it was 1/3, it would be just a cube root. All right, so you're going to do your antiderivative. If you add 1 to that, so you have to raise the power, then it would be how many thirds? Good. So you guys are good at the fractions. And that means in front, it's 3/5, such that 0 to 3. And then I'm not playing with that anymore. What I wanted you to get was the antiderivative. So like, I'm fine with leaving the answer like that. I just wanted you to practice the fractions. If you plug in 0, you just get 0. You can write -0 if you're a purist and you want to have it all be nice and perfect. This is going well. A lot of people find these easier than the cross sections because they're all circles. You don't have to worry about what kind of shape you have. All right, this one, I made it like the same root problem so we could like just reuse the same drawing. All right, so we're gonna revolve the region in the first quadrant bounded by this thing and the two axes. All right, let's get some points for this graph. What can we plot? 0, 4. What else? Good, it's gonna go like this. Perfect. You want to visualize that kind of ahead of time. What else can we plot though? 1, 3. Don't worry about the buy one, get 1 point. We're gonna erase that anyway, because we want the part in the first quadrant. All right, and then I'd like one more. 2, 0. Good. So this is the shape that we're looking at. And if you could just go ahead and draw that in the grid below it as well. I did that on purpose so we could just reuse our work. I was trying to like make it a little easier on you. And so I have one going over the x-axis and one going over the y-axis. So we're going to do one of them as a dx problem and one of them as a dy problem. So go ahead and draw your like ghost shape over the x-axis. And just to check and see if your imagination is working and you're able to visualize that, like what would you say this looks like? Like if you're envisioning that as a 3-dimensional thing. Oh, like half of a yoga ball? Half of an egg? Or you know what I think of? It would be like a little too deep, but like a pitcher's mound. Do you know what I'm talking about? It'd be circular and then like kind of domed up. Okay, good. But you guys are there with me. All right, cool. So it is going to be pi r squared dx. And so you want x values for your boundaries. 0 to 2, perfect. And your radius is upper minus lower. So it would just be that graph minus 0. Again, if you're revolving around the axis, it's going to be 0, which is nice. So it's just that graph, which is 4 minus x squared. I am going to have us do this one by hand because I've seen them have ones like these on the non-calculator part. If you need to do 4 minus x squared squared, if you can do it in your head, that's really awesome. But what it means is this. Do you see what I'm saying? Okay, so let's just see if our algebra skills are still intact. What's that going to give us? 16 is a good start. And then there will be an x to the 4th at the end. We want to minus how many x squareds? Good, 8 x squared, minus 4 and minus 4, and then plus x to the 4th dx. Sometimes you have to do that. So I'm just making sure your algebra skills are there. And then what is our antiderivative? That was the algebra. Now here's the calculus. 16x, good. And pi sits out front. I don't say that every time. It's just kind of there. All right, minus. Good, perfect. And then plus. Good, such that 0 to 2. And then you just plug in 2. You guys know how to do that, right? Like just plug in 2. Okay. This is the calculus. That's the part I want to make sure we get. All right, and the setup. It's the setup and doing the antiderivative that is the important part. That you just plug into. All right, I'll fill that out when I take a picture of it. All right, so this time we want to spin this around or revolve it around the y-axis. So you draw your ghost shape over there, and this time your discs go this way. So it's going to be right graph minus left graph. I kind of can't fit an L in there. Can you guys sort of see that? Right, left? I don't know. So this setup is going to be pi r squared dy. So your boundaries will be y values. So 0 to 4. I should get that on top of that. Sometimes, like, there are years where I have to fight with that. Like, people just don't see it. You guys are just seeing it. It's awesome. Now, you have to stop what you're doing. It's going to put the brakes on this. You have to go back to this equation and do what to it? Good. Okay, so let's do some algebra. What would you do there? Minus 4, I'm just going to write in the margin up here. Y minus 4 equals negative x squared. divide by a negative. So it would be negative y plus 4 equals x squared. Okay. I've seen them do this and it's evil. When you square root, you are supposed to put, did we use, when we drew the original shape, the positive side or the negative side? So you want the positive square root, but I have seen them do ones where it's the negative square root, and the answer will not come out the same if you don't have that negative in there. So just be really careful, okay? So we want the positive square root of this. What was it? Negative y plus 4 equals x. All right, so this is the thing that we're looking at. So since that is the right graph and the left graph is just 0, that is what goes into your parentheses here. And we'll be able to do that by hand as well, because like the other one that we did, those cancel. So antiderivative would be negative 1/2 y squared plus what? 4y, good. Such that 0 to 4, and then you would just plug in 4. I'll go back and fill that in before I take the picture again. Like the setup and the antiderivative is the part I'm concerned about. That's like, you guys can plug numbers in, not trying to waste your time. All right, these last two, as a heads up, we're going to revolve around something that's not the X or Y axis. It is the same process. It's just when you do upper minus lower or right minus left, one of them's not 0 anymore. Do you get what I'm saying? You shifted it. Okay, you'll see what I'm talking about when we draw it. All right, find the volume of the solid generated by, big red flag here. What do you think this probably means? Probably a dy problem, okay? That is a sideways parabola. So you're going to get 0, 0, 1, 1, and negative 1, and then 4, 2, and negative 2. If you want to make a table, you always can. It's just that one was kind of basic. It's just a regular old parabola, except sideways. And then we've got x equals 4, so this vertical line here. And so this is the shape that we're looking at. But it doesn't say we're revolving around the x or y axis. It says we're revolving around. Okay, so usually I'll just leave that like dotted in, or you can just draw it as a solid line. But anyway, this is the axis we're spinning around. So your ghost shape is going to end up over here. And can you, I know you're all busy drawing it. Can you look at me, point to this for 1 second? Do you see how it's like we took the y-axis and just scooched it over there? That's the other way you can remember it's dy. It's like you just took the y-axis and moved it over, but it's still like you're going around the y-axis. And just to make sure your imagination is working, what would this look like 3-dimensionally? Like envision it as a 3-dimensional, like a football, right? Okay, just making sure you're seeing it. All right, pi r squared dy. And do the setup, or you're going to forget the square, right? We want y values for our boundaries because it's dy. So that would be where to where? Get -2 to 2. And then again, watch me point to this. It's going to be right graph minus left graph. So right, left. So the right one's 4. Good. Hold on a second. Just to make sure everybody's there. 4. See how it's not 0 anymore because we scooched it over? 4 minus this one, which is y squared. Good. I'll let you just put that one in the calculator because we did one very similar to that right up here. Do you see how this was 4 minus x squared? This one's 4 minus y squared. So I'll let you just put that one in the calculator. Well, because calculating is an important skill too. So we'll just type that one in. Oh, and I know it says y, but please type x. Oops, what am I doing? Square, there we go. Can anyone confirm? Yes. Okay. If you got a way smaller number, you probably forgot this squared right there is going to be my guess. Or did that go okay? Okay. One more. Let's see if I can do this in 4 minutes. All right, find the volume of the solid generated by the region bounded by. All right, that's going to be an upside down parabola. if I do run into time and the seniors leave, I am just gonna finish this. It'll be on the recording. You can just go, but I'm gonna finish this to end my recording. All right, y equals -1, so horizontal line at -1. This is our shape. So it's actually like pretty tiny. And what does it say we're spinning around? The line y equals -1. So if you want to like dot that in at -1 so you can see it, but it's like you just took the x-axis and scooched it down a little bit. So that's the way you can remember it's dx. You just took the x-axis and moved it down, but it's going to be dx. Okay, so everything is right side up. So that's your setup. Pi r squared dx, pi blank squared dx. So you want x values, good, so it'll be -1 to 1. And then watch me point to this. It's upper graph. Oh, I didn't draw the ghost shape. Your ghost shape is here. It's gonna almost be a sphere, but not quite. Do you see how it would be like a little off, like a wonky sphere, right? So it's gonna be upper graph minus lower graph. Which one is the upper graph? -x squared. Oh, good. Let me get everybody else there. It would be minus, the lower one is -1. And so you could just put +1 if you wanted. And again, we did one where I made you multiply that out by hand, so we'll just type this one in the calculator. And seniors, you do have time to type it. I finished it. It wasn't that long of a problem. Please humor me. The button pushing is a skill that you need. It should look like that. My pi is there, it just went off the screen. And confirmation? Okay, cool. Sweet. What do you guys think? Do you think this is easier than the cross section?